Okay, big stuff, no pressure, but this is your introduction to the natural logarithm, which you're going to see other times in other classes in the future. So, the natural logarithm is expressed as ln.
Alan! Alan!
That's an
Alan!
ln, not an
Alan!
in,
Alan!
ln. And you think,
Ow!
well, wouldn't it be an l? Well, yeah, but welcome to math. So it's going to be ln is because it's French or Swiss or something European that I can't pronounce. Anyway, it's ln. So
Alan!
when you look at your
Alan!
calculator,
Alan! Alan!
and for most of you that would be Desmos, there's ln.
Alan! Alan!
Ah,
Alan!
snap.
Alan!
That's what that button
Alan!
does. So you know what the log button does now, right? That's base 10. Well, ln
Alan!
is log base e. And we do a quick search on E, and E is known as Euler's number. Yes, that's how you pronounce it. Or in some cases, the Napier constant. And this is what you see right when you Google it. Quite a few results. It's base of a natural logarithm. Ah, snap. The first few digits are 2.71828, blah, 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 blah. It goes on forever. Interesting graph right here. It gets more complicated, as you can tell. It's used in finance. And we could go on and on about this, right? Why is E so special? Purpose, numerical value, exclamation mark. It's like math is cussing at us finally. Crazy. Okay. So anyhow, oh yeah, interesting. Big takeaway is that there's two buttons on your calculator: a log button and a natural log button. ln.
Alan! Alan!
Okay. And then
Alan!
anytime I
Alan!
invoke
Alan!
ln, I also invoke log base e. Okay. So we're talking about two special bases in this class: a common log base, which is 10, and the natural log base, which is e. Okay. Those are the only two we're looking at: 10 and e. Those are the special bases that we're going to focus in this class. Problem 5, inverses. So if I had this is going to go back to functions, right? If you forgot inverses, I'm going to do this only once because I need you to see what it is and why. Okay, but if you're kind of curious about what an inverse is, go back to last semester. We did videos on inverses of functions. So I'm going to go ahead and do that process like we did back then. We would change f of x to y. And we would solve for x, get the x by itself. Now to do that for this problem, I would need to use ELB. The exponent is the logarithm of the base. So the exponent is x is equals logarithm, log, base e. And then the y goes here. And then if you remember, what we did at this point is we transformed it, right? Complete with sound effects. Those are horrible sound effects. That's my transformer sound effects. Okay. So this is the inverse. Now, let's clean this up a bit. What is log base e? ln.
Alan! 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 Ow! Alan!
So we started with an... We got to make this very, 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 very clear. We started this with an exponential. And when I did the inverse, I ended up with a logarithm. So huge takeaway. The inverse of an exponential is a logarithm, and the inverse of a logarithm is an exponential. And that's how we define logarithms when we first began talking about them in this class. So let's look at these special cases of natural log. And let's find out what they are equal to. So let's go ahead and start off with making it equal to x like we did in previous videos where we evaluate. And recall that natural log can be written as log base e. So if I do ELB on this thing, the exponent is the thing by itself. The base is e. Making this into an exponential, we get this result. But e to what power is 1? anything to the 0 power is 1. So natural log of 1 is actually equal to 0. Let's try the same thing with this one. Set equal to x. So that's going to be log base e equals x. And we go ahead and do ELB on this as well. So e is going to be the base, x will be the exponent. Well, this is interesting because we actually have the same bases. So we have the same bases, the exponents are equal to each other. So we get x equals 1. So natural log of e is actually equal to 1. And if you remember, right, if you remember the logarithmic patterns assignment that you did, and the patterns that you saw with the base and the argument, if they are the same, then the answer would be equal to 1. For this one, we could do it a couple of ways. Let's make this equal to x, and let's actually begin with the power, right? We could do this, put it in front. Don't forget, natural log is log base e. And then we would actually divide both sides by 2. Because I want the log to be by itself. So I have log e equals x over 2. And then we could do ELB. So if I do ELB, that's e x over 2 equals e. Well, it's e to the 1, right? So we have the same bases. So I can make this x over 2 equals 1. What number divided by 2 is 1? Well, 2 divided by 2 is 1. So x equals 2. So this answer would be 2. Now, there's a different way we could have done that. And you might like this way better. So if I write it as log base e squared equals x, we could do ELB on here. So e is a base, the exponent is x, and the argument is e squared. Now, interestingly enough, it's the same base. So the exponents are equal to each other. And I get the same blankety blank answer. So it's equal to 2. Now, we kind of knew that also from the logarithmic patterns assignment because, you know, you have this idea of the argument being the same as the base, right? So, okay, cool. Problem 7 is just for kicks, I guess, for now. Let me show you how this would work out. So this looks like an impossible problem to work on. The x is an exponent. We divide both sides by 17 first. We get e to the 4x equals 5 because 85 divided by 17 is 5. And then I would do ELB. The exponent is the logarithm of the base. In other words, this is 4x equals natural log of 5. I want the x by itself, so divide both sides by 4. And I get this answer, C. I'm still debating if I want to have you do more of these types of problems or not. I'm sure you don't want to, but I'll promise you that when we get to trig pre-calculus, we will do a lot more of these problems. So we'll see what happens here in the near future. But just pause this problem 7 for now, and we will let that simmer in the background. Summary. I'm going to ask you 2 questions for your summary. 2 of them. 1. Give examples of 2 special bases for logarithms. And the second one is to explain what the relationship is between logarithms and exponentials.
Alan! 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 Alan!